Hello friends, welcome back to Scientific Blunders, where you learn the don'ts first. So today we're going to kickstart a new series on permutations and combinations, and this is one of those chapters where it is so hard to identify the mistakes because what seems like a right method can give you a totally different answer. And I personally have made, I think, several blunders in this area, and I just wanted to share some of the mistakes I made so that students can benefit from it. So let's get started. Here's the problem we have. From a bunch of 4 mangoes and 6 apples, find the number of ways to select 5 fruits containing at least 1 mango and 1 apple. So we have a bunch of 4 mangoes and 6 apples, right? And just to be clear, each of these are unique mangoes and apples. So it's almost like we have M1, and this is a mango like color, right? So M1, M2, M3, and M4. We have 4 mangoes and we have 6 apples. So apple 1, apple 2, apple 3, all the way. Actually, let me just write all of them. Apple 5 and apple 6. Okay. And of these 10 fruits that we have, we want to find the number of ways to select 5 fruits containing at least 1 mango and at least 1 apple. Okay. So we have 10 fruits, we want to select 5, and there's this restriction that we have to have at least 1 mango and 1 apple. So, if I actually saw these 10 fruits in front of me, this is how I would do it, right? So of the 4 mangoes, I would first choose 1, correct? Where I pick 1 mango, and then of the 6 apples, I will choose 1 more. Let's say I choose A2, but I have 6 choices here actually. So 4C1 times 6C1, okay? 4 choose 1, some people say choose, but essentially I'm picking 1 out of 4 mangoes, 1 out of 6 apples, and then I need to pick a total of 5, so I have 3 more to pick, correct? So how many options do I have now to pick from? Well, I need to pick 3, and of the 10 I've already picked 2, right? Which means I have 8 left. So I pick of the 4 mangoes, I pick 1. Of the 6 apples, I pick 1 more. And then of the 8 remaining fruits, I can pick any 3. It doesn't matter because I already satisfied the condition of having 1 mango and 1 apple, right? And so this evaluates to 4 times 6 times 8C3 is 8 times 7 times 6 divided by 3 times 2 times 1. Okay. And if I did my math correctly, this should give us 1344. Okay. And we are done. Are we? Well, one good check that I recommend in all of these problems in permutations and combinations is to establish an upper bound and see whether your answer satisfies that. So what exactly do I mean by an upper bound? So for example, let me just scroll down a little bit first. Okay, we have 10 fruits of which we want to select 5, correct? We have 10 unique fruits, right? This M1, M2, M3, M4, A1, A2 all the way to A6. So 10 unique fruits out of which we want to select 5. Okay, so the total number, if there were no restrictions at all, okay, let's say there's no restrictions, you can pick any fruits, you don't have to satisfy this condition at all. How many ways are there for you to choose 5 fruits from a bunch of 10? So that is 10C5 or 10 choose 5, correct? And that is an upper bound to this number, or that should be an upper bound to this number, because this is just, you have 10 fruits, you have to pick 5, no restrictions at all. So you consider all possible combinations. And now when you add a restriction, the number should only go down, correct? So this should be an upper bound on this number, okay? And that is a good check, right? To make sure this number is correct. So how much does this give us? This is 10 factorial by 5 factorial squared, correct? And this gives us 252 if my math is correct. Okay? Wait a second. didn't we say this is going to be an upper bound on this? So we're saying, if you have 10 fruits and you can select 5 with no restrictions, there are 252 ways to select. But when you add a restriction, you have more ways to select it. Well, I think something is wrong here, right? Something seems wrong about this number now. Because 10 choose 5 or 10 C5 is definitely correct, because you have 10 unique fruits, 5 ways to select it. Oh, sorry, you need to select 5, so there are 10C5 ways or 252 ways. When you add a restriction, this number should only go down. Okay, so we did something wrong here, and I really encourage you to pause the video here and think about this. And this is a very, very, very common mistake in permutations and combinations. So this is totally worth analyzing now, so that the same mistake is not repeated again. So hope you're back after analyzing this a little bit. Okay, and before we think about what exactly happened, let's try another way to do this same problem. Okay, and a way that to me seems to be more robust to things like these, that is likely to give us the right answer when we consider different cases. So what do I mean by that? So let's say, so M is mangoes, A is apples, and I just want to pick five fruits containing at least one mango and one apple, right? So let's just manually write down the combinations, right? I can pick one mango and 4 apples, or I can pick 2 mangoes and 3 apples, or I can pick 3 mangoes and 2 apples. Okay, let me extend this. Or I can pick 4 mangoes and 1 apple, right? And these are the only combinations, right? Because we need to have at least one mango and at least one apple. So you cannot pick 5 mangoes and no apples. Okay, so these are the only combinations. And how many ways can you pick 1 mango and 4 apples from a bunch of 4 mangoes and 6 apples? Well, that is unambiguous, I think. It's 4C1. So of the 4 mangoes, you want to pick 1. And of the 6 apples, you want to pick 4. Okay, 6C4. Right? The same thing of 4 mangoes. The second case, right? These are cases. Okay, let me call them A, B, C, and D. Okay. So case B, you want to pick 2 mangoes from 4 and 3 apples from 6. So 4C2 times 6C3. Case 3, you want to pick 3 mangoes from 4 and 2 mangoes from 6 apples. 6C2. And case 4, you want to pick 4 mangoes from 4 mangoes. And there's only one way to do that. And you want to pick 1 apple from 6. Okay. So, and the total number of ways you can pick should be the sum of these, right? Because we are summing up all of the different cases. Okay. And let's do a little bit of math here. So how much is 64? Okay, we have to do some mental math. Let me change colors so that don't confuse. Okay, 64 is how much? 15, right? 63 is 6 into 5 into 4 by 3 into 2 into 1. I think it's 20. 4C2 is 6. 4C1 is 4. 4C3 is 4C1, right? I'm going to change this to 1. 62 is 64. So this is the same as this. So we'll calculate this and use the same number here. 4C4 is 1. 6C1 is 6. Okay. And let's go back to our old color. Okay, 15 fours are 60. 26 are 120. And 4 times 15, right, is again 60. And this is 6 times 1, 6. So 120 plus 120 is 240 plus 6, 246. So now in this method we have gotten the answer that there are 246 ways to select 5 fruits containing at least 1 mango and 1 apple from a bunch of 4 mangoes and 6 apples. And in this case, we do notice that this is a lower bound, this is an upper bound to this, right? So this number seems to be correct to me. But what I cannot understand is what was wrong with this method. This seemed perfectly correct, right? So you have 4 mangoes, you want to pick one. You have 6 apples, you want to pick 1 apple. And then of the 8 remaining fruits, you want to pick 3. So 4 times 6 times 8c3 is 1344. And why is this number so high? What exactly went wrong here? So to understand this, what we are going to do is a slightly different problem. Okay, let me just push this down. Yeah. And the reason we're doing a different problem is so that we can use smaller numbers and we can actually manually count things. Okay, so that we don't have to rely on the theory of counting, but we can just manually count things, and this way we can actually understand this concept clearly. Okay, so from a bunch of 2 mangoes and 2 apples, find the number of ways to select 3 fruits containing at least 1 mango and 1 apple. So you have 2 mangoes and 2 apples, and you want to select 3 fruits containing at least 1 mango and 1 apple. Okay, now what was the first method we did? We say, okay, you select one of each, okay, and then you select the remaining from the remaining. Okay, let's just think about that. Okay, let's do the same thing again, but this time we can think about it clearly. Okay, so I want to say I want to select 1 mango from 2, and then I want to select 1 apple from 2. Okay, and now let's say I selected this and I selected this, and now I have 2 remaining, right? And I have to select 3 fruits totally. I've selected 2 already, so from the remaining 2 I want to select 1 more. Okay, you get 8. Now is this correct? Okay, so I'm sure we learned our lesson now, right? This is likely to be wrong, because it's very similar to the example that we just did here. It is, it's going to be much higher than the upper bound, right? Or maybe equal to the upper bound. Let's do, the other case by case method and see what we get this time. So you want to select, this is how we did it, right? Mangoes and apples, right? Mangoes and apples. You want to select 3 fruits containing at least 1 mango and 1 apple. So you can select either 1 mango and 2 apples or 2 mangoes and 1 apple, correct? So it's either 2c1 times 2c2, which is 2, or it's 2c2 times 2c1, which is also 2, which means if we sum these up, there are 4 ways to select 3 fruits. Okay, now which one of these is actually correct? Well, let's do it manually. Okay, I want to select 3 fruits from these 4, okay, such that I have at least 1 mango and 1 apple. Okay, so how many ways can I do that? So I can either have M1, A1. Let me just do the mangoes and apples, 1 mango and 1 apple first. Okay, so M1, A2, M2, A1, M2, A2. Okay, now once I have M1, A1, I can pick either M2 or A2, it doesn't matter. So let's say I pick M2. Okay, what if I picked A2? Okay, well, you will see that case is already going to be counted elsewhere. Okay, or let me actually show you what happens. Okay, so M1, A1, I can pick either M2 or A2. So let me show both actually. Okay, now M1, A2, I can either pick A1 or M1. Okay, let me scroll down a little bit to create some space. And then M2, A1, I can either pick A2 or M1. And finally, M2, A2, I can either pick A1 or M1. So now I have 8 combinations, right? 1, 2, 3, 4, 5, 6, 7, 8. Now, are all 8 of these unique? So for example, I have, how do I, let's try to highlight the same combinations, okay? M1, A1, M2, that is one combination, right? Is this unique? Is there an M1, A1, M2 anywhere else? M1, M2, A1. Yes, there's an M2, A1, M2 here. So these two are actually the same, but we actually double counted that, correct? And maybe I should have done this whole thing here. But isn't this actually what we just did when we did 2C1? So essentially you're saying you can pick either M1 or M2. You said then you pick either A1 or A2. And then of the remaining ones, you pick either one, okay? And this is how we got 8 combinations, right? But now we realize that we are double counting because M1, A1, M2 is the same as M2, A1, M1. The order doesn't matter because these are not permutations. These are just combinations. We're just looking at the collection, not the order in which we select. Okay, so already we have seen one case of double counting. Let's see if we can find anything else. So there's M1, A1, A2, right? There's this case, M1, A1, A2. Is that present anywhere else? Well, it's repeated right after here. So there's M1, A1, A2. So that is another case of double counting. Okay. And anything else? Let's see. M1, A2, M1. Oops. Did I make a mistake here? This should have been M2, I think. Okay. Yes, the others seem correct to me. Yes. Okay. So M1, M2, A2. Is that present anywhere else? Well, that's right here. M1, M2, A2. So another case of double counting. And finally, there is M2, A1, A2, right? And that is again double counted here. So how many unique colors are here? 1, 2, 3, 4. So there are only 4 unique combinations. 4 is the right answer. And that is what we got here, right? When we did a case by case. And the 8 that we got here is a case of double counting, right? And I hope this simple example illustrated why this is the case. And now in this case, this is exactly what happened here, right? We selected one mango from 4, one apple from 6, and then when we did the 8C3, this is actually the part where the mistake occurred, because here is where the double counting occurred, which means that this number is wrong, and clearly this was wrong because this violated the upper bound. Okay, and so I hope this example was helpful. And I think this chapter has so many problems where these silly mistakes can occur, and so I think the lesson to be learned from this video is the way I like to handle problems in permutation and combination is I try to visualize. When you do 2C1, I try to it's almost like you're looping over all the combinations, right? So when I write the term 2C1, I try to visualize, okay, there's M1 or M2, and I just loop through all combinations, right? So as you try to visualize this in your head and you loop through, you will automatically get a feel whether you are double counting or not. And we can get that feel here because see, let's go to the more complicated example. Now I'm picking 1 from 4 mangoes, 1 from 6 apples, okay? There's no double counting so far, okay? But now when I pick 3 from the remaining 8, there is a possibility for double counting, right? Just loop through your head. So here there's M1, M2 all the way to M4. And now here there is A1 all the way to A6. And now I think this is correct so far. And when you pick 3 fruits from the remaining 8, I hope you get the feel that, I hope, especially after seeing the example, uh, excuse me, I hope, especially after seeing this example, I hope you get the feel that there is some double counting that's happening here. So you selected 2 already. Let's say these were the ones that selected. Now of the remaining 8, as you select 3, I hope you understand there is some possibility of double counting here, right? Because let's say you picked M1 here and then you picked M2 here. But then when you pick M2 here and you pick M1 here with the fixed A, that is going to be, you're going to double count combinations here, right? And that is very hard to detect as you're, especially if you have a time constraint, you want to quickly solve the problem. It's very, very tricky. But I hope this example was useful. And if I had to give you, one takeaway, I would say, and this is probably the biggest, most general takeaway for this lesson, is always check for double counting. And the beautiful way to do that is that, we always generally have an upper bound. We have like a worst case, and that's very easy to calculate. Always check for double counting using the upper bound. Okay, and with that, I hope you found this video useful. And this is a beautiful lesson, and we will definitely be doing many more videos in this series. And see you all in the next video. Bye.